What's up, everyone? Sam here from byte.com, and in this video, I'm going to give you the top 8 algorithms that you need to know for your coding interviews. And if you want tons more tips and strategies for preparing for your interviews, go to byte.com/masterclass and check out our free coding interview masterclass. All right, so as I said, I'm going to give you 8 specific algorithms that you need to know for your coding interviews. But before I get into that, I want to make sure that you actually have the tools to be able to apply these in the most effective way possible. I see so often people focus on just like memorizing the one thing. They'll like write out the code or get code online and they'll literally try and memorize it line by line. And that is like the least helpful thing that you can do for preparing for your interviews. So the most important things to do when you are learning these algorithms is to focus on really actually understanding the algorithm itself. Each of these algorithms is going to have tons of different variations. They're going to have tons of ways that you adapt them to different problems. And what you want to focus on as you are learning each of these is understand that core algorithm and then make modifications. Understand the ways in which you can adapt these to different situations. I love saying, okay, well, let me say I'm doing depth-first search, for example. I'll start with a really simple version of depth-first search where I'm just seeing if a node is included in a tree. And then maybe I'll adapt that algorithm. I'll say, okay, now I know that the node's in the tree. Could I find the path to that node? Could I find the path between two different nodes? How can I continue adapting, modifying, making the algorithm slightly more complex so that I really understand the algorithm itself and how that works rather than just what the code was for this one specific solution? And so with that out of the way, that's how I want you to focus on each and every single one of these algorithms. But let's go ahead and get into the specific algorithms that you need to know. So the first algorithm that's really, really important, and is not really one algorithm, but more a set of tools, is data structure manipulation. And this is so important because a lot of times what I find is that people learn algorithms around a specific data structure, but they don't actually learn how to use that data structure. And so more important than anything else before we get into any of these algorithms is that for each data structure you're going to use, you need to deeply understand how that data structure actually works. So let's use a simple example of a tree. In a tree, we have a series of nodes that have different values. And so what we want to do before we get into any algorithms around the trees is think about what are the basics of manipulating that data structure. How might we construct a tree? How might we insert or remove a node from a tree? How might we find a specific node in that tree? These are all things where I would encourage you to think about, like, what would the standard library look like for this specific data structure, and what are those things that I would assume would be part of that standard library? For every data structure, we want to know how to construct it. We want to know how to do these basic things, because if we don't know how to do those, it doesn't matter all these other algorithms because we don't know how to work with the data structures. So algorithm number 1 is manipulating every single data structure that we need to know how to use. Number 2 is searching. And this is a classic thing with depth-first search and breadth-first search. I'm combining these both into one because they accomplish the same basic goal, but really we need to know how to search between nodes in a tree, nodes in a graph, and also how to apply this to other sorts of problems. There are tons of problems where we might say, okay, well, let me find a path between 2 words in a dictionary that only vary by 1 letter. Right, so I might say there's this example if you look up word ladder problem on LeetCode, where we basically have a dictionary and we have 2 words and we can modify characters in that string 1 character at a time to go from one word to the other. And this is an example where we would use a depth-first search or a breadth-first search to try and actually identify a path between 2 different states. So understanding both how to use depth-first search and breadth-first search in a graph or tree, but also how to apply it in these sort of more abstract cases where we're essentially constructing like a theoretical graph of data between finding connections between 2 different states is super important. Number 3, combinations and permutations. This is something that I see come up all the frickin' time. This is one of my favorites because it's actually quite tricky to do. You have to understand recursion and you have to understand how to generate these clearly. But then once you understand how to generate all combinations or all permutations, you can solve so many different problems with that basic understanding, with that basic algorithm. Some examples of this might be anytime I want to say, find the best this, or find the best combination of inputs. I can do that by just generating all the combinations and then filtering those down to find the best one. A classic example is the 0-1 knapsack problem. In the knapsack problem, what I'm doing is I'm trying to find what combination of items that I have the greatest value while minimizing the weight of those items. And an easy way to solve this, not the most efficient way, but the easiest way to solve it, is to just find all combinations of items, and then I can just check each one and see what is the value of each combination of items to identify then which is the best result for my given input. And so this is why combinations and permutations are so valuable, because they're fundamental to so many other things that we might want to do. Algorithm number 4 is sorting. And there are lots of different types of sorts that we might want to do. There's quick sort, merge sort, insertion sort, etc., etc., etc. But understanding the basics of sorting is really, really important. And I want to be clear with this one for a second, because this is an interesting case where most of the time we don't need to use sorting to actually sort our input, right? This sounds weird, but when we are solving problems in our interview, if we need our input to be sorted, if we need something to be sorted, we're not going to implement the sorting algorithm ourselves. We're going to use some sort of built-in sorting algorithm. But the reason why this is so important for us to understand is because the concepts can be extrapolated beyond just fundamental sorts. There's so many cases in which we might want to do things like a partitioning algorithm similar to a quick sort, where we could do like a quick select. And we might not know how to do quick select, but it's something that we can extrapolate from understanding how quick sort works. And using these different sorting algorithms, I love them as a foundational tool because they teach so many strategies within them, so many things that we can apply in other places. So understanding how to implement these sorting algorithms, also understanding in your language how to sort arbitrary data structures. This is something that also comes up a lot, where we may have a data structure where we may have a custom wrapper for our data, where we have a couple different data points, and we want to sort it based on one of those fields. Do you know how to do that in your language of choice? If not, that's something that you want to understand how to use the built-in tools for sorting as effectively as possible. Number 5, binary search. And this is similar to sorting, where it is not necessarily something that we're going to be applying a lot directly, but we may be applying it in more complicated circumstances, or in other ways we would be using strategies from that binary search in our problem. A classic example of a problem where we might use binary search is in a rotated array, identify like the pivot point. And so what that means is that we take an array and we have, yay long array, we split it down the middle and we swap the sides of the array. And so there was a point where it goes like, 7, 8, 9, 10, 1, 2, 3, 4, 5. And so what we would want to do is identify that point where it was rotated. And we can use binary search for this, but it's slightly more complicated. So remember what I said at the beginning about it's not just understanding what is the algorithm line by line, it's understanding how it works. And so if you understand how binary search fundamentally works, what that process is for identifying, like, I'm splitting my array and then which side am I looking at, if you understand that, you can extrapolate and think about, like, how would this work? And I'd encourage you to try this problem on your own, because if you understand binary search, then that allows you to do all sorts of other things that are really, really important in your interviews. Algorithm number 6 is topological sort. And this is a funny one, because this one I think is probably the least common of all of these, but it's really, really useful because when we are looking at graph problems, we basically have to do 2 or 3 things. We have to do depth first search and breadth first search, which we already talked about. We need to deeply understand that data structure. And then basically any other problem that we would want to do with graphs would be topological sort. Topological sort is basically allowing us to sort based on like prerequisites or preconditions. So it allows us to sort our nodes in our graph based on which nodes are pointing to which other nodes. And so what sort of problem we can solve with that is any sort of scheduling problem or any sort of thing where there are like prerequisites. So if we said, okay, well, what order do we need to compile these binaries in, where different ones have dependencies on different other binaries? Or which order do we need to take courses in, where one course has a prerequisite of another course? Anything where we are trying to order our data in a specific way based on any sort of restrictions, topological sort is the thing that we are going to need to use to do that. And our final 2 algorithms go hand in hand here they're recursion and dynamic programming. These are both pretty broad topics, and we actually have a bunch of resources for these over on bytebybyte.com. You can check out bytebybyte.com/recursion for our post on recursion that goes a lot more in depth about the 6 different recursive patterns. And we have a free ebook on dynamic programming at dynamicprogrammingbook.com. But both of these are really important because they sort of represent a different paradigm of programming. Recursion is very different than a lot of the other stuff that we do, and so it's important for you to understand because it's so different. It's something that is not so easy to just kind of come up with on the fly unless you've really been preparing for it, unless you actually really understand recursion. And dynamic programming is just so important because that is a tool that we use constantly to optimize our solutions for tons of different problems. And so with that, again, those are the 8 algorithms that you need to know for your interviews. We have data structure manipulation, searching, depth first search and breadth first search. We have combinations and permutations, sorting, binary search, topological sort, recursion, and dynamic programming. And if you understand these, if you understand sort of the underlying principles of each of these algorithms, you're going to be much better prepared for your coding interview. And so with that, that's all I got for you. If you enjoyed this and want a lot more resources on coding interview prep, go to bytebybyte.com/masterclass and check out our free coding interview masterclass. If you like this video, please give us a like and subscribe. It really helps our video in the YouTube algorithm. And I look forward to seeing you in the next one.